Here's a couple of demos for you for this chapter. Ask yourself, do you ever really touch anything? What's on the outside of your skin? Electrons. What's on the outside of the paper? Electrons. When I go to touch it, I just get so close. The electrons are repelling the electrons. So what we call touch is the sensation of this repulsion. We can demonstrate that. You get your magnets and you hold them so that they're facing each other so they'll repel. You put them on the tips of your fingers and then you move one past the other. You can actually see these fingers move. It's like I'm feeling an impact. There's nothing touching, but if it goes past there, you can't help it, it's going to move. So that's the model that we're talking about, repulsions, making it feel like you're getting hit. Now you can't feel it if you just watch the video. You got to go get your own magnets and do this. And it would be best if you could do it to somebody else at the house. Have somebody else hold the magnet and let them feel it. Now let's move on to a model for a bond. Normally you see these stick models. You have an atom, you have another atom, and they get shoved together onto a stick. The stick represents the bond, but it doesn't move. That's a problem. Could you imagine using a rubber band? Now when I pull it apart, it wants to come back to this position. If I push it together though, it's not going to want to come back to this position. Well, they do make some chemical models with springs, and that's a little bit more realistic. They can bend. You pull them apart, they want to come together. You push them together, they want to come apart. Hey, that's not a bad model. But the problem with all of these models is that there's still a piece of matter between the two atoms. Really, a bond is made up of forces of attractions and repulsions that are balancing, but we don't have a solid between them. How about we use the magnets to try to create a model for a bond? I'm going to take this magnet, leave it on the table. I'm going to take this one and try to tilt it and bring it up. Oh, it doesn't, it wants to grab. I'll flip it over. I'll tip it up and bring it in. And as I get closer, I can feel it wants to stay. This is a model for a chemical bond. Gravity is pulling this magnet down, and that magnet is pushing this one up. So they're in equilibrium. The forces cancel out. The net force is zero. There's no matter in between here. It's not like a stick or a spring. This is a reasonably good model for a chemical bond. Now, it might be possible for me to get the second magnet to balance. There we go. So in matter, we have one atom, another atom, another atom, and it just keeps on going like this. And each atom can affect the next one down the line. All right, I know you only have two magnets, but you're not too far from a hardware store if you want to get more. And you have to tape them because when they clack together, they will break. Here's another fun little demonstration. I've got a thread taped to the table at the bottom with a little paper clip on the end. That's the magnet, rubber banded to a rod, just being held up by the soda bottle. And this is again the idea of a few forces adding up to zero to create an equilibrium. There's nothing in between here. If I disturb it, it wants to go back to the equilibrium. Of course, there's a limit to it. If I push too hard, I break the bond. So what are the forces? We have gravity, we have the tension in the string, and we have the magnet pulling up. At this point, they all add up to zero. It wants to return to the equilibrium. Nothing in between. You can do it at home and you can feel the force